Alright, so let's talk about probability. So in this section we're going to talk about two types of probability, theoretical probability and empirical probability. We're also going to talk about games of chance, but it should be noted we're not going to teach you how to gamble or advocate for gaming. But what we found is games of chance have some good rich uses of probability. So let's start with theoretical probability. An occurrence for which the outcome is uncertain is called an experiment. The set of all possible outcomes of an experiment is the sample space. We're usually going to use this capital S. An event, denoted by E, is any subset of a sample space. The theoretical probability of an event, which I'll usually write as PE, is the following. So it's the number of outcomes in event E divided by the total number of possible outcomes. Shorthand you may see is the number of things in E over the number of things in S. Probabilities are always a number that can be expressed between 0 and 1, or 0% to 100% inclusive. The closer a number is to 1, or 100%, is more likely it's going to happen. So the probability of an event can be written as a decimal, a fraction, or percent. In the homework, you'll be asked all three of those, so you have to be able to kind of differentiate between them. All right, so this is not really an example of probability, but this is kind of a result you see. So you got a fraction, 6/8. The reduced fraction is 3/4. The decimal is 0.75 or 0.75, and I'm getting that by just doing 6 divided by 8 equals 0.75. Okay, and you can, my math lab accepts both. So let's talk about this a little bit. So this is the reduced fraction. Reduced fraction. In my math lab, not in my math lab, in your calculator you can actually reduce a fraction. I want to show you that real quick. This doesn't work 100% of the time. If the numbers are too large, then maybe the calculator needs some help and you have to reduce it a little bit. We'll see that later on. But 6 divided by 8, there's a couple of ways you could do that. So if you type it in, you get the number. You can do second PRB, and it reduces it. So let's do that again. 6/8, when you have the decimal, so to convert, a decimal to a reduced fraction. You got the decimal, you do second PRB. Second PRB. All right. You also could have done this. I don't use this one as often because I find it doesn't work for me as much. But when you write your fraction 6/8, you could use the fraction button here, ABC. Looks like that looks kind of weird, but that'll reduce the fraction. So you could try that as well. But like I said, sometimes I have trouble with that. So these are your decimals, if it wants a decimal. In this case, it's not rounded because 6/8 is exactly 0.75. Sometimes it's going to ask you to round. And then 75%, of course, is the percent. And briefly, I'll mention this. If you have if you want to convert a percent to a decimal, so if you're converting a percent to a decimal, just remember you got 75% is equal to 75%, right? Well, what is percent? Per 100, so it's over 100. So if you're given a percent and you need to convert it to a decimal, that's how you can do it. Also, if you want to convert a decimal to a percent, you're going to move the decimal 2 units to the right. So if that comes up, you may have to do a little bit of thinking about that. Let's go ahead and move on. Get to an example here. So let's start with some easy examples. Okay. So here we have a 12-sided die. Now I don't have a 12-sided die with me, but I think you can kind of understand it. So the set of equally likely outcomes is, of course, 1, 2, 3, 3, 12. So it says find the probability of rolling a 5. So on this example, I think I'm going to rewrite my sample space for each of these because I want to mark on it, and if I try to mark on the same sample space multiple times, it could be confusing. For the questions you're going to have in the homework, most likely it's just one of these 4. So you're only going to have to write it down once per question, generally. So the probability of rolling a 5. Well, now I have to first figure out how many 5s are there. Okay, so the number of ways to roll a 5, well, there's only one 5. So there's only one way to roll a 5. Of course, the number in the sample space is 12. There's 12 things. So the probability of rolling a 5 is the number of 5s over the number in your sample space. And notice I'm usually going to use this little S like this to indicate that it's a S and not a 5. My 5s and S's kind of look the same. So earlier we had the number of 5s is 1, the number of things in the sample space is 12. 1 over 12 doesn't reduce, and so our answer is 1/12. All right. So I'm going to go ahead and draw my sample space for part B, so I can mark all over it. So this is simple probability. Anything more complex we'll talk about later on. All right, so the probability of rolling an odd number. Well, probability of rolling an odd. So the number of odd things, let's go find them. 1, 3, 5, 7, 9, 11. So an odd number is any number that's not even. An even number can be divisible by 2. All right, so 1, 2, 3, 4, 5, 6. Makes sense that half of them are odd. All right, so and we know that the sample space is 12, number of things. So the probability of an odd thing is going to be 6 over 12. Now you might know that reduces to 1/2, but let's go ahead and do it ourselves. 6 divided by 12, you get 0.5. Second PRB, you get 1/2. Or we could do it this way. So it's fewer buttons that we're touching for the second way, but like I said, I usually just try to convert it after. All right. Probability of rolling a number greater than 9. Well, there's the thing. If it's greater than 9, just greater, then that means we do not include 9. So not 9, but 10, 11, and 12. So know the difference between greater than and greater than or equal to. Had it been greater than or equal to, you would have included 9. So the number of things greater than 9, sometimes I'll use that little greater than symbol. That is 3 of them. So the probability of greater than 9 is 3 over 12. Of course, that's 1/4, but 3 divided by 12, second PRB, 1/4. You should get to where you recognize or are able to reduce these in your head, but if you can't or you're on a test, just use the calculator. All right, I have one more from the group of dice rolling questions, and then we'll move on to a deck of cards. We'll talk about that briefly. All right, so let me write this out. All right, so probability of rolling a number less than 21. So we're not including 21. Well, that would be numbers like 20, 19, 18, 17, 16, 15. Well, that includes everything in this list. Every single one of these numbers is less than 21. So the number of things that are less than 21 is all of them. That's 12 things. So the probability of less than 21 is 12 over 12, which you shouldn't have to do that by hand or by the calculator. And that's 1. So it is 100% true that anytime I roll a 12-sided die, I will get a number less than 21. All right. So now we have a standard deck of cards. I brought a standard deck. For some students, a standard deck is familiar. For some, it's not. And so we're going to go through, I'm going to show you all of these things. So a standard deck of 52 cards has 4 suits, hearts, diamonds. So let me find you. That's a heart, diamonds. Those are red. And then spades and clubs are black. Okay. So you saw some of these have faces and letters and some do not. So each suit has 13 values. So I'm going to try to find all of those. Well, probably not for the sake of the runtime of the video, but we've got some aces. So let me just find all of my aces. That'll work. All right, so they each have an ace, but then they have these numbered cards, and the numbered cards are 2, 3, 4, 5, 6, 7, etc. Up to 10. 10's the highest number card, but then you have face cards. Let me find you an example of face cards here. So the face cards are Jack, Queen, and King. All right. So there's a total of 52 cards in a deck. 4 suits. Diamonds and hearts are red. Clubs and spades are black. That's the basics you need to know. When you go through the homework, sometimes they'll use some of that stuff. But is it necessary to buy a deck of cards? No. If you're at the supermarket and you see a deck of cards for like $1, you can grab that and that'll help you with the homework. But you can't use a deck of cards on the test. So you're going to have to know these at some point. If you Google standard deck of cards, you can find a picture of the entire deck in one picture, and you can refer to that as you do the homework. All right, so the probability of being dealt a 5. So first of all, the number of things in our deck, the number of things is 52. So that number is going to pop up a lot. The question is the probability of being dealt a 5. So how many 5s are there? You can go into your deck of cards and you can find every single 5 if you would like, or you could look at that picture, or at some point after a handful of these homework questions, you'll know that there are 4 5s in a deck of cards. So that's 4 over 52. Even if it doesn't reduce, you can try to reduce it. And if it doesn't reduce, then it doesn't reduce. But 4 over 52, oh, you get this weird decimal. That's not familiar. Second PRB, 113. Okay. All right. And then the last one on this page, before we move on to the next topic, find the probability of being dealt a heart and a spade. Okay. Probability of a heart and spade. Remember, you're only dealt one card. So if you're dealt one card, what's the probability that is both a heart and a spade? So there's an example of a heart, and there's an example of a spade. So you should notice that there's no possible way a card could be both a heart and a spade. So it's kind of a trick question. So 0 over 52, what is 0 over 52? Believe it or not, some students will say that is undefined. Okay, some students will say it's 0. If you get confused, which you shouldn't, but if you get confused, type it in the calculator. You'll see that it's 0. Okay. These are things we should know, but sometimes when you see zeros and fractions, students will confuse that with the undefined. All right, so that's enough theoretical probability. Let's talk about an empirical probability example. Empirical probability applies the situations in which we observe how frequently an event occurs. So this is about surveying or taking data, whereas theoretical probability was considering you have all these things together, how likely it is you're going to pull one of them. So this is going to actually be based on data, collected data, or what the book calls data. Same idea. It's the observed number of times E occurs divided by the total number of occurrences. So the hours of sleep that citizens get on a typical night is shown in the table. A researcher in sleep deprivation finds that the average human needs at least 6 hours of sleep. What is a probability a citizen will get at least 6 hours of sleep? So this one I pulled from the homework. At least 6 hours of sleep, that means 6 hours or more. So in my table here, I'm looking at these rows. 6 hours, 7 hours, 8 hours, 9 hours, and 10 hours or more. So what I need to do is I need to total up the number of ways to get greater than or equal to 6 hours, which is found by adding up these numbers. Anytime I have to add more than 3 numbers, I usually recommend doing that calculation twice. Because this is one small calculation in the entire problem. So if I miss this, I get the whole thing wrong, even if the rest of the steps are correct. So 75 plus 95 plus 85 plus 12 plus 9, 276. I'm going to do it one more time, although that number looks familiar. So 75 plus 95 plus 85 plus 12 plus 9, 276. All right. But I still need to know the number of things in my sample space, which is found by the total amount of people. And I find that by just adding up all of these numbers. Okay. Since I've already added the ones in pink, I can just add 9 and 15 to get 300. But, again, if you want to double check yourself, you can add up all of these numbers again. Okay, and I did it a second time, I got 300. So the probability that someone will get greater than or equal to 6 hours of sleep is going to be 276 over 300. So, I think this is going to reduce some because 276 is even, 300 is even. So second PRB, so it is 23 over 25. This is the reduced fraction. Sometimes with these empirical ones, they may just want the decimal, so I'm going to give you the decimal too. So 276 divided by 300 is 0.92. So I'm going to give you that one and then remind you that this is the decimal. So decimal. And in this case, I didn't round because it's exactly 0.92. But if they want the decimal, sometimes they also want you to round it to a hundredths place or a thousandths place. And then the last question we have is a bit of a doozy, but it's so unique to what we've talked about, I feel like it's important that we actually do this one together. Okay, so this one is the dartboard question. This is still using simple probability. It's an application where we have areas going on, but I'm going to show you how to do this. I think you'll only see one in the homework. The good thing is, if you get it wrong, you can redo it. Watch this video again. Alright, so you can see I've done a little bit of construction here. Well, I've only got one colorful printout. And so if I mess up my page with the printout, I'll have to go and print more. I don't want to do that, so kind of worked around it. So I'm going to work my work over here. Alright, the target in the figure shown to the right contains 4 squares. If a dart is thrown at random, hits the target, find the probability that it will land in a green region. Type your answer as an integer or simplified fraction. So, here we go. I guess the first thing we have to remember that the area of a square is s squared. So this is a fact we have to know. So there's a little bit of geometry, most of us know that. Or could figure it out. Students would also say length times width. Well, if all the sides are the same, meaning it's a square, then it would be s squared. All right, so what I have to do, the first thing I'm going to do is find the amount of stuff in the sample space. And the amount of stuff in the sample space is the area of the large square. Okay, the large square is 25 inches. Well, I don't have to write the inches. I probably should, but then we get into units and dealing with like how to square inches. So I'm just going to keep it simple. Do 25. You can do 25 times 25, or you could do 25 squared. There's a button. There's also a caret button here if you want to do it that way. So 625. That's going to be our denominator. Okay. This is going to be our denominator. So what we have to do now is we are going to find the area. Well, I guess we have to find the total area of the green. Okay. So I have something I'll refer to here. So I want to find the area of this green frame. Basically, in order to find the area of the green frame, I need to find, so I guess first, find area of the green frame. Now notice the green frame here is a square, and it removes this blue square, and then that as well. So what I'm going to do in order to find the area of the green frame is I'm going to do the that green square, which is 20 squared, and I have to subtract off the blue square. Now this blue square has the green square inside, that doesn't matter, but I do have to subtract off this blue square. Okay, so that's 5 squared. So I'll write that down. This is the green square, the outer green square. This is the smaller blue square with the green frame. Okay, that's what's going on there. So this number 20 squared is 400. In fact, you could do all of this together. Minus 5 squared, which you should know is 25. You could have done that all together. So 20 squared minus 5 squared is 375. All right. The total green area is going to be the green frame we just found, and now I also have to find the area of the small green square. So I'm going to get to a bit of a shortcut on this one in just a little bit, so just bear with me. So the area of the small green square that's 5 inches, so 5 squared is 25. All right, so the total area of green, I'll just do it up here. The total area of green is 375 plus 25. Oh, I made a mistake right here, so let's catch that. Here we have 20 squared. The blue frame here is 15. So that's going to change just that. So 15 squared is 225. 225. And so this number, 400 minus 225, is 175. Okay. So 175 plus 25 is 200. So the total amount of green is 200. So the probability of green will be 200 over 625, because the 625 was the total. So divided by 625, second PRB, you get 8 over 25. All right, so let me show you a bit of a shortcut on this one. What I mean by shortcut is it turns out that let's see, so probability of green, it's always going to be the green stuff. We're going to, with the exception of the large square, so this is still going to be my denominator. Whatever is the large square is the denominator. But then the shortcut here is, as you kind of follow these numbers, if it references a green square, it's positive. If it references a blue square, it is negative. So I got 25 squared on the bottom. 20 squared is this green one. 15 is this blue one. And then this 5 is this green one. And so that's a bit of a shortcut on this one. So 20 squared is 400. 15 squared is 225. You could probably actually do all of that denominator at once. And of course, 5 squared is 25. And then that's 625. So let's clean up the top real quick. 400 minus 225 plus 25. Got my 200 again. Divided by 625, which we already know is 8 over 25. So, there is that terrible question. It's very long, but it is a good one. But on the right here, on the left here, is the kind of a shortcut we could use.